So 125 and 64 are both cube numbers. And our x is cubed and our y is cubed. So we can go straight to writing this in the form where they're all written to the exponent of 3. And you can hit the math 4 to get to your cubed root if you do not have them memorized already. And you will after this lesson because we just write it so much. Excuse me. So this cube root of 125 is 5 and the cube root of 64 is 4. So I can rewrite this as 5 to the third power x to the third power minus 4 to the third power y to the third power, which is what we want to happen because in algebra we're allowed, once we have everything to the same power, we can simply focus on the bases and not have to work with the exponents anymore. So I can rewrite this now as 5x minus 4y. Since we are subtracting, I'm going to use the formula of a minus b times a squared plus ab plus b squared, where 5x is my a and 4y is my b. Colors are almost the same, I'm sorry. Okay, so plugging that in here, my a is 5x, so 5x, and I'm going to square that, which is 25x squared. A times b would be 5x times 4y. 5 times 4 is 20, keeping the sign, this should be positive. Okay, so we get 20xy, and my b is 4y. Take 4y and square that, so 4 squared is 16, y squared is y squared. Okay, on number 2, you'll notice that our exponents are not 3s, right? So we need that to be 3s. So what I am going to do here is kind of review the power to a power rule. So the power to a power rule says if I have a power raised to another power, then you multiply those powers, right? So I'm looking for the factor pair using a 3 to make 12. So I can rewrite this as x to the third power raised to the fourth power minus y to the third power raised to the third power. Okay, I knew I wrote that wrong. So what I want is the 4 to be here and my 3 to be on the outside. Because again, if they're all raised to the same power, I can ignore that outside power and just focus on my bases. So now I can say, okay, it's x to the fourth minus y to the third, and that's going to be my a and my b. So here's b. Okay, so using my formula for a minus b would be a squared, opposite sign, ab, always positive, b squared. Okay, so here for my a squared would now be x to the fourth power raised to the second power. And again, my power to a power rule tells me to multiply those. So now my first term would be 4 times 2 is 8. X to the 8th power. A times b. Well, when you're multiplying, you can just put them next to each other. So x to the fourth, y to the third. Always positive at the end. And then I get y to the third power raised to the second power. Again, power to a power rule tells me to multiply. 3 times 2 is 6, so y to the 6th power. And that is my answer. I'm going to type all of that into the box. On the next one, when we have two binomials that are identical except for the signs are opposite, What we can do to save us from distributing all the way is all you have to do is distribute the first to the first, and I get a squared, and then the last to the last, and I get negative 81. That is our answer. It only works when, again, they're identical binomials except the signs are opposite. It's a little trick here because our middle terms will end up canceling out. Okay, next one where I have a binomial squared. You can go ahead and expand that out. And then I'm going to FOIL it or go over, over, under. So I get x squared plus 10x plus 10x plus 100. And you'll notice these middle terms you end up adding. So eventually you'll start to see that pattern where all you have to do is square the first and then add the two constants and then square the constant. There's a pattern there that happens every time, but be careful because the sign is adding. And when it's subtraction, you'll have a subtraction symbol show up in your answer. So just be mindful of those patterns as we look for these shortcuts to solving these. So our next problem, we get to see the pattern on what happens when we are finding the difference of two binomials that are identical. So over, over, under here, I get 9x squared. 3 times negative 2x is negative 6x plus 4. So the first terms get squared, and then 3 times 2 twice, 3 times negative 2 twice gives me negative 12x, and we square the last term. So we can actually write two formulas from this that will help us skip this step in between where we can go straight to from here to the solution. So when we have adding, the formula is a squared plus 2ab plus b squared. And when we are subtracting, we get a squared minus 2ab plus b squared. Okay, so once again we're looking at two binomials that are identical except for their opposite signs. So we can multiply the first and the last terms. And that is our solution.